Hello there. Today we'll be working on this problem of figuring out what the sum of 2 over the quantity of 2 squared minus 1 plus 2 over the quantity of 3 squared minus 1 plus 2 over the quantity of 4 squared minus 1 plus and so on and so forth is equal to. This question looks sort of difficult to sink our teeth in, right? Because it goes on forever, and each of these expressions, each of these terms, they seem a bit unwieldy, like 2 over this difference of squares on the bottom. What are we supposed to do with that, right? One thing we can try is maybe try out the first few expressions. So for example, we can try to find 2 over 2 squared minus 1. This would be equal to 2 over 3, right? And then plus 2 over 3 squared minus 1. So finding 2 over 2 squared minus 1 plus 2 over 3 squared minus 1, that's going to be 2/3 plus 2/8, and so on. And maybe we can hope to find some sort of pattern. However, this process does not look like much fun. And even if we do find a pattern, we can't really be guaranteed that that pattern is actually going to continue on forever, right? So another way we can do this is we can approach this using a method called telescoping. Telescoping is basically, I don't know if you've ever done this sort of method before, but basically what you do with telescoping is you sort of rewrite each of these expressions into some other expression, and then maybe somehow all of those the new expressions will somehow cancel out with one another, and then we might be left with some expression that's maybe a bit more manageable. For instance, if we were to sum 1/2 minus 1/3 plus 1/3 minus 1/4 plus 1/4 minus 1/5, and so on and so forth, we can telescope this, so to speak, by noticing that these two would cancel out, right? So this negative 1/3 would cancel with this 1/3, and this negative 1/4 would cancel with this 1/4, and so on. So all of these things would cancel, and we would be left with something nicer, right? So in this case, what we want to do is sort of rewrite these expressions, like I said, so to make it hopefully not be able to collapse somehow. By the way, the reason this is called telescoping, if you have difficulty remembering it, is because this is referring to those old-timey telescopes that are sort of like a bunch of tubes connected together, and then the hope is that you can sort of compress this, or you can sort of compress these telescopes so that it's only one pipe, right? So similarly, here we have this really big, nasty expression, and we want to sort of compress it and telescope it to make it smaller and more manageable. All right. So the way we might rewrite this expression is notice that this is 2 over a difference of squares. And a difference of squares, we all know, can be rewritten as a product of two things, right? We can rewrite this as 2 divided by 2 minus 1 times 2 plus 1, right? So this is going to be 2 divided by 1 times 3. And then the reason this is nice is that notice that this is actually going to equal 1 over 1 minus 1 over 3. And the reason, right, because this is 1 times 3 minus 1 times 1 divided by 3, which makes 2 over 3. And the reason I sort of automatically saw this sort of expansion of this expression is because usually with telescoping, like the example I showed you before of the minus 1/3 plus 1/3 and so on, usually what we want is we want some sort of number minus another number, and then hopefully it like the subtraction term can somehow cancel out with some other subtraction term, right? So here I saw 1 times 3 on the bottom, so I figured maybe I could try 1 over 1 minus 1 over 3, and luckily it would. So similarly, 2 over 3 squared minus 1 can be written as 2 over 3 minus 1 times 3 plus 1, right? Which is going to be equal to 2 over 2 times 4, which is equal to 1 over 2 minus 1 over 4. I encourage you to check my work, but this should be correct, right? Because this is going to be cross multiplication 4 minus 2 divided by 2 times 4. All right. So then, similarly, this next term is going to give you 2 divided by 4 minus 1 times 4 plus 1, which is going to be 2 divided by 3 times 5, which is going to be 1/3 minus 1/5. And notice at this point that you can start canceling things out, right? This 1/3 can cancel out with this 1/3. It's negative 1/3 plus 1/3. Those two can cancel out, which is great. And so with this, we can sort of tell that we're probably on the right track with this telescoping process. So in general, notice that when we have 2 over x squared minus 1, we can rewrite this as 2 over x minus 1 times 2 over x plus 1 times x plus 1, which is going to be equal to 1 over, this is going to be equal to x plus 1 divided by x minus 1 times x plus 1 minus x minus 1 divided by x minus 1 times x plus 1, right? Because these x's would cancel, which would leave you with 1 minus negative 1, which is 2 on the top. And this would be equal to 1 divided by x minus 1 minus 1 over x plus 1. So all in all, the way we can rewrite this is as a sort of sum from 1 over 1 minus 1 over 3 plus 1 over 2 minus 1 over 4 plus 1 over 3 minus 1 over 5 plus and so on and so forth, with each term being written as like 1 over x minus 1 minus 1 over x plus 1 and so on and so forth, right? Each expression is going to look like 1 over x minus 1 minus 1 over x plus 1. And this is basically what we want because let me write out some more terms here. The next term is going to be plus 1/4 minus 1/6, right? And this is what we want because this 1/3, like we said, cancels with this 1/3, and this 1/4 cancels with this 1/4. And most likely, and all of these negative terms are going to cancel with all of the positive terms beyond, right? So these would all cancel, and that would just leave us with 1 over 1 plus 1 over 2, which I think is really amazing. Just like this entire expression just boils down to 1 over 1 plus 1 over 2, which is just 3/2. Isn't that so cool? Just like this huge expression, this huge, really quite terrifying expression just becomes this itty bitty little thing. All right. That's about it. I'll see you next time. And pause.